While it is possible to survive without food for up to 30 to 40 days, we can only live without water for 3 to 4 days. There are numerous places in the world where fresh water is scarce, so people try to do everything they can to get hold of potable water. There is an abundance of seawater in the world, but it is dangerous to drink it in large amounts because its high salt content can lead to dehydration. A small home distillation apparatus is enough to desalinate a small amount of water, but large-scale technology is required to satisfy larger needs. Desalination plants are usually built on coasts. First, water is purified mechanically. Then, there are several methods used for desalination. The simplest one is distillation, which is also used by the plant in this animation. Its purpose is to remove salt from the water by boiling it. Several blocks, all containing heat pipes, comprise a distillation unit. Hot steam is pumped into these pipes, while the unheated seawater is sprayed from the top onto the surface of the hot pipes. Seawater cools the flow of the hot steam, which condenses into fresh water inside the pipe and flows out at the bottom. At the same time, steam from the heated seawater is conveyed into the heat pipe in the next distillation block. Desalinated water is collected from the heat pipe in the distillation block, while the concentrated salt water exits through the bottom of the distiller. Steam coming from the last block is reintroduced into the first one through a thermocompressor, which increases the pressure and temperature of the steam. The ion exchanger desalinates seawater with electrically charged rosin beads. These are filled into a container in which an outlet pipe is located. Seawater is added to the container from the top. Then it flows to the bottom through the pores between the beads. As the water flows, the rosin beads bind the salt content of the seawater, and the accumulated water flows through a filter into the opening. Finally, the desalinated water leaves the container through the outlet pipe. Initially, there are positively and negatively charged counter-ions on the surface of the electrically charged rosin beads. These are hydrogen and hydrogen oxide ions from the water. The ionic strength of the positively charged sodium ions and the negatively charged chloride ions in the seawater flowing through the pores is higher than that of the counter-ions, repelling them from the surface of the rosin beads. As a result, the sodium and chloride ions bind to the surface of the beads, and the repelled counter-ions form water molecules again. After a while, these beads cannot bind any more salt, and they need to be regenerated. The drawback of the ion exchange method is that very strong acids and alkalis are required to clean the sodium and chloride ions from the surface of the beads, which in turn can cause serious harm to the environment. During electrodialysis, seawater is pumped at a high pressure through membranes, to which electric current is applied. The ions in the seawater bind to the membranes with the correct charge. The negatively charged chloride ions bind to the positively charged membrane, that is, the anode, while the positively charged sodium ions bind to the negatively charged cathode. After a while, the surfaces of the anode and cathode cannot bind any more salt and have to be cleaned. An electric current is also required to clean the surface of the electrodialysis cell. Normally, salt ions bind to the electrically charged surfaces. Therefore, while they are being cleaned, the flow of the electric current is reversed, so the ions separate from the surfaces of the anode and cathode. The removed salt ions exit the cell compartment together with the water. Desalinating water by reverse osmosis relies on the difference in size of the salt and water particles, rather than depending on their ionic strength. During the process, water is pumped at a high pressure into the pressure vessel, in which a multi-layered, semi-permeable membrane made of a special plastic is placed around a tube. The high pressure forces seawater through the layers. By the time seawater passes through all the layers, the membranes will already have filtered all the salt, and the desalinated water exits through the outlet pipe. Salt held back by the membrane accumulates in another outlet pipe and leaves the pressure vessel as a concentrated salt solution. Reverse osmosis is one of the most widespread methods of desalination. Moreover, it is one of the most environmentally friendly methods too, as it does not require any hazardous chemical reagents.